Thank you so much for having me. Thank you to Felix and the entire SRNTE for organizing this. So I'm going to present a scoping review and meta-analysis. Just first want to acknowledge funders and all co-authors involved in this work. The paper is actually out in Nicotine and Tobacco Research, and we just got an email last week that it has been assigned an issue, I want to say in August, and was selected as editor's choice article. So it's going to be open access indefinitely, which was great news. So if you're interested in reading more about this, it's online and available. So we were interested in looking at remote ways of biochemical verification. Obviously, as you all know, digital and mobile interventions are on the rise. I don't have to tell you the pandemic we just went through that severely limited in-person interactions with participants. So there is a greater and greater need to verify smoking cessation outcomes, for example, with your participants in absence of being able to have any face-to-face contact. And so we started out with this idea of just doing a scoping review to see what's out there. And then it kind of spiraled and went to a meta-analysis. But so the goals of the review initially were to look at what types of samples are collected for biochemical verification remotely, which biomarkers are used and methods of verification. And then how is participant adherence encouraged? Like what kind of approaches are studies implementing to get high return rates? What study outcomes obtained and reported? For example, return rates, self-reported abstinence, biochemically verified abstinence, the number of or percentage of samples that are valid, that can be used for analysis, those sorts of things. And then how do some of these study characteristics relate to study outcomes? We included all kinds of studies that remotely obtained biochemical verification of participant smoking status. I will say that some of these used remote and in-person approaches in combination, but all of the studies we included at least used some remote biochemical verification. And we did this for combustible tobacco use. So we excluded exclusive focus on smokeless, on vape products, or other forms of nicotine or tobacco. And we also kept an exclusive focus on non-tobacco combustible. We excluded studies that exclusively focused on non-tobacco combustibles, such as cannabis. I want to say there was maybe one study in that it did biochemical verification for tobacco and cannabis, but that was certainly an exception. And then we also excluded studies that only did on-site staff-administered verification of smoking status. We dug through a lot of papers to just come to a final sample of 82 studies that were included in this. And so because it was a scoping review, we ended up categorizing studies into 3 different categories. So the main category that we were initially interested in were literally just the smoking cessation intervention studies that exclude contingency management. So those studies typically would have a type of intervention that gets delivered and then a primary outcome at a certain follow-up point that then would biochemically verify those self-reported outcomes. Contingency management studies are a little bit of a different animal because most of the time the biochemical verification serves as a type of intervention. And some of the studies then, when they might also look at an outcome later down the road after the contingency management part is over, but then and use maybe biochemical verification for those outcomes as well. But for the contingency management studies, we usually just focused on the actual contingency management part where participants, for example, have to provide abstinence samples, multiple times per day in order to qualify for the incentives. And then we had another category of other studies. There was sort of studies that didn't fit in any of these first 2 categories. So those included usually feasibility studies, validation studies of a new type of device for biochemical verification, and secondary data analyses. And so for analyses, we ended up doing random effects meta-analyses of proportions, so proportions of self-reported biochemically verified abstinence, to estimate the percentage of rates of return samples for all studies. Random effects, because there was substantial heterogeneity, obviously, across categories, massive heterogeneity. That's why we didn't even start comparing those. But we also, so we didn't do comparisons across study types. But within these categories, there's also a lot of heterogeneity. That's why random effects meta-analysis is more appropriate. And then we looked at self-reported biochemically verified and the concordance between biochemically verified and self-reported abstinence rates in those smoking cessation intervention studies without contingency management only. And then finally did meta-regressions to investigate the relationships between study characteristics, like, for example, what types of samples were collected, what biomarkers were used, and study outcomes. So, for example, like, which of these studies had better or worse return rates. So these are the main findings table. Overall, what we're seeing here, and I'm just going to go into the overall study category first. Expired air and saliva were the most common samples collected. The most common, makes sense. The most common biomarkers used were carbon monoxide and cotinine. And then in the verification method used, most common was video, followed by mail-in samples that were then subsequently analyzed in the lab. For the samples collected by the study type, also makes sense that you would see most commonly expired air used in contingency management studies, just because that usually provides a more rapid turnaround. Whereas in the smoking cessation intervention studies, most commonly studies collected saliva samples. We also looked at what type of approaches studies used to increase adherence. And for that, we just categorized into 3 different categories. So did these studies train participants in how to return or how to collect those samples? Did they provide incentives? And did they remind people if they didn't provide samples? And then we also just added up the number. So you can see that a lot of the studies used some type of measures, but if we add them all up, there's only a small minority of studies that used all 3 of these. And I will say that, in part, this could be just due to the fact that this is not necessarily reported in those papers. So that's definitely a limitation right there. Looking at the meta-analysis outcomes. So this is for the sample return rate. So the first 3 slides here I'm going to show you are all sample return rates for the different types of studies. So this is the main study category, smoking cessation intervention studies without contingency management. And just to orient you to the slide, I'm always going to refer to the random effects model. As I said before, the random effects model is the most appropriate due to the heterogeneity of the studies. So here we're seeing a random effect of 0.71, which essentially translates to 71% of the requested samples were obtained. In contingency management studies, slightly higher, 77%. And in other studies, slightly lower at 65%. So now, back to the smoking cessation intervention studies, looking at self-reported abstinence rates. And again, here, the random effects model. So these are the studies that, would collect, first of all, would ask people about their smoking status and then subsequently biochemically verify their self-reports. Usually, I'd say most studies do this only in people who report abstinence, just to conserve resources. Some studies do it for all participants, but that's definitely the minority. So a little bit over 20% self-reported abstinence rates here in the random effects model. What does it look like for biochemically verified abstinence? 9.5% biochemically verified. And then we did the ratio of biochemically confirmed to self-reported abstinence. And here the random effects model comes out to 47% of those reports of abstinence are then subsequently biochemically verified. And because you saw before already that we had sample return rates in those studies, in the smoking cessation studies, of roughly 70%. That tells you that, the sample return rates are obviously responsible for some of that gap, but they're not responsible for the entire gap, right? So usually folks who don't return samples are counted as still smoking per default. And so not that entire gap is accounted for by the lower return rates. In the meta-regression results, we looked at smoking cessation intervention studies without contingency management, so that main study category. When we looked at study characteristics and sample return rates, we found no significant differences by study characteristics. Interestingly, we also didn't find significant differences depending on what types of approaches and how many approaches these studies implemented to increase adherence, which, I don't know, I was surprised by and struggling with this finding a lot. I think in part what we might be seeing here is just that not everything is reported in these original studies. And then the study characteristics and the ratio between biochemically verified and self-reported outcomes, we found that compared to video confirmation, there was a lower ratio in photo confirmation and mail-in samples. So what we take from this, first of all, sample return rates need to be improved in these studies. I think that's pretty clear. There was no association between return rates and approaches to improve adherence. So as I said before, the question here to me is, are these systematically reported in studies? Because we can really only work with what is reported in the papers. And so the next point here, only approximately half of self-reported abstinence was biochemically confirmed. We're seeing similar but slightly smaller issues for this in in-person studies. So in-person studies also have this issue of a gap between self-reported and biochemically verified, but the gap tends to be smaller. And obviously we need to investigate reasons for lower return rates and the mismatch of abstinence reports. And those reasons are not entirely clear. Are people not returning their samples because they're still smoking? That's obviously might be one reason, but also maybe because the procedures are too cumbersome, because they don't understand what is being asked of them. So there are all kinds of potential reasons. So in sum, we came up with these reporting recommendations for studies to report return rates, usable samples, self-reported and biochemically verified abstinence, and the number of concordant or discordant results. With detailed reports for each study subgroup, which would be helpful. So intervention and control group, for example, in trials. We need to report an account for other tobacco product use, obviously, depending on the biomarker used, and increasingly cannabis use, especially for combusted cannabis use. Report identity verification of who provided samples. Some of the newer studies are doing this with photos or video confirmation, because with mail-in samples, you really don't know who's providing the sample, if you're perfectly honest. And then include and report study approaches to increase these return rates. And one way to improve sample return rates, for example, we just published a paper that is just fresh, hot off the press with Roger Villadarga at Duke, where we review strategies to investigate those sample return rates and focus on the importance of user experience design research. And with that, I'm just going to leave this one up for the Q&A. And thank you so much for your attention.
Fantastic. Thank you very much for taking us a tour on that complex review. Really interesting and helpful work. While I wait for any questions to be added into the Q&A part, I just wanted to share my own sort of experience with this. And one potential reason, I don't know if you were able to sort of factor this in, for lower response rates among people who self-report as abstinent is a delay between when they report their self-reported abstinence and then when they get an opportunity to verify that. And certainly we found with postal saliva samples that can, for whatever reason, take like a week to get to them. And often we verify people who have abstinent for only 7 days or more. So relapse rate's probably quite high if they have only recently started abstinence. So I wondered, was that something you were able to kind of look at within the studies, or could that be another factor that explains the sort of the ratio issue?
Yeah, it's a very good point. I wonder, if what we're seeing, you may remember that the meta regression of the ratio between biochemically verified and self-reported tended to be higher in video confirmation studies, which, video confirmation is easier to do around the same, very closely tied in time to self-reported outcomes. So that might actually be an indicator that some of that could be going on. I will say that, with the increase in access to technology, while we did the review, it took us some time to finish up the first draft, and then the search was outdated, so reviewers made us redo the search. So that gave me an opportunity to also look at more recent studies that had come out during the pandemic. And I will say that there is definitely a trend going towards more carbon monoxide breathalyzer mobile device confirmation, which is much easier to do in real time, because you're getting closely tied to the self-report. People have the devices, they plug into the phone, and a lot of the studies are doing either photo or real-time video confirmation with identity verification of facial recognition. So there's a lot of development happening in that space. So keep an eye out on the most recent studies. But that's sort of my read of the landscape, is it's definitely going in that direction.
Absolutely. And I remember talks on the SRNT conference in March this year, looking at all kinds of ways of remote verification with sort of proof of who was providing that sample or breath test. And I'm sure at the SRNTE conference and next year's SRNT conference in Edinburgh, we'll see more and more of this coming through. So Johannes, thank you so much for that really interesting talk, and a big thank you to all our speakers today. It's been really fantastic to hear cutting edge work going on within the society, and thank you everyone for attending.